up. Let's just take a moment. I know I need to take a deep breath. Let's just close our eyes, take a deep breath. Just recognizing that we're on stolen land of the people in the Housatonic sub-watershed.
Yeah, man, that was awesome.
River watershed. And just giving you a moment to like connect with your watershed, wherever you live, or maybe your family is from, where you grew up maybe, or where you are now. Tapping into the land there, and the First Nation people there. Maybe the quality of water there. And our intention for this presentation is just to provide an example of efforts for watershed restoration, reclamation, and offer ideas for you all where you live. So the watershed we're focusing on is located in Vermont, as settlers call it Lake Champlain. The Abenaki First Nation people of that land call it Lake Fitwabak, Lake Between, which is between the Adirondacks Mountains and the Green Mountains, between the Abenaki people and the Mohawk people, between the Haudenosaunee Confederacy and the Wabanaki Confederacy. It's a pretty large lake. It's the sixth largest lake in this country, and as you can see, a lot of wetlands, 300,000 acres of wetlands, which are great points to be in touch with in terms of places for water quality, health checking in on, as well as the fact that there's 54 public and 10 private beaches. So those are all kind of like key points to keep watch on when you're trying to monitor health. One of the neat things about this lake is that it's not only between two states, New York and Vermont, but it's also between two countries. And so there's a lot of potential for like beyond boundary watershed restoration collaboration. So our hope is the techniques we're exploring and developing practices for can be then practiced on like all sides of the lake. So like most freshwater lakes in the modern world in this country, it has a lot of threats mostly from phosphorus, from agricultural runoff, and excess inputs, and then bacteria from nutrient loading, and then your host of PCBs, microbeads, all the non-point source toxins. Climate change, and its accompanying, I like to use the term emerging species. Some people call it invasive, but that's a whole other topic. Some people think those species are actually ecosystem placeholders. So I'm going to use the term emerging. That's a different topic for conversation, but worth noting, for example, one of the mussels that's considered invasive is actually like filtering water of current toxins that just showed up. So it's just like an interesting thing to think about. So the seed for this project was planted in 2009. I used to teach at a Waldorf school in East Montpelier, Orchard Valley. I ran like an environmental program called Earthwalk. Earth Crafts. I was also teaching at Earthwalk, and took like one of my classes on a camping trip. It's located on a sweet spot along the Kingsbury branch of the North Branch of the Winooski of Lake Champlain. And it was like a pretty wholesome camping trip. We had a really solid water filter. And the kids, like most kids, got pulled to the water, and we spent like a lot of the day in the creek. And like most of us playing in the water, sometimes you get like a gulpful in your mouth and you swallow it. So a couple days after the camping trip, I got like a panic phone call from one of the parents just saying like, hey, did you have like a solid water filtration system? And we're like, yeah, we totally did. The kids also were playing in the creek, and like some did swallow some water, and they're like, well, one of the children was like on dialysis, his kidney was failing, and it was like we didn't know if he's going to make it through the night. Scariest like scenario. Turns out he's fine now. He's like leading Knowles wilderness trip somewhere. But that was scary, and it was most likely, I'll get to the strain of E. coli that it was, upstream. So that's located in the sub-watershed in East Montpelier, which ends up, and there's like a pretty pronounced known dairy farm, like just upstream that I've been watching for a couple years. Mismanages its manure, and again, this is not to like put down dairy farmers. I'm friends with a lot of dairy farmers. I work with them. They're doing the best they can. They're between a rock and a hard place. A lot of them want to like take care of the environment and actually are. I'm also not talking about the dairy farmers that have grass-fed and like repairing buffers. I'm talking about the 80% that's commercial, that's doing corn, that just has trouble managing their manure. So pretty much the trail, like they're pretty much like up this hill next door and over here, and all the water funnels down. So this is kind of like, and the creek that the kids were playing in is down there. So yeah, it obviously all ends up in the ocean. We're just trying to stop it as far up as we can. So we're focusing on E. coli. There are a lot of different pollutants you could, but because of that story, and also just because it's one of the pollutants that we actually have found research that fungi can work with and degrade, we decided this is a great place to focus. One thing worth noting about Vermont is that it has a bunch of really amazing watershed restoration groups that have a very kind of regular schedule in testing water. And so like every spring, every summer, every fall, they have all these different, so there's like a pretty good data set on E. coli numbers and locations. And so it's kind of known like where the hot spots are, and we'll get to levels in a moment, but like where the beaches are closed and where the places that when there's a big rain, those are the areas that we have problems of runoff, and just needing filtration systems on the terrestrial, keep it in the terrestrial, don't get it in the aquatic. So hydrology, just knowing topographical hydrology, how the land flows, and like paying attention to runoff. Couple just things that we had to think about in working with E. coli was it's super important thinking about like precipitation when you're doing tests based on rain, based on season. Also certain areas might have higher bacterial levels due to other things that are happening on the land. And then a kind of concerning fact, geez, can you read that with the wrinkles? Is that, yeah, it's okay. Okay, great. It's just that we found out that sediment actually can create habitat for E. coli, which is kind of humbling because in some sense, like certain levels of sediment might prevent erosion, like when it's on the terrestrial, but that's kind of concerning because the last thing we want to do is like create more habitat for E. coli to live. E. coli itself, you know, we all have it in our gut. It's a facultative, anaerobic, non-sporulating, gram-negative bacteria. It's really good at reproducing, and a lot of strains like help us and lots of animals stay healthy and great. It's just that when you have a different strain and it gets in the wrong place, it's not in your gut, it enters your body in a different way. The strain that that student had, I'm pretty positive based on the data we got and information, was 0157.117, which if you just have a tiny bit, like 10 of them, it just leads down to kidney or something that happens in our metabolic system. It just shuts things down quick. So that's just scary to know. Another thing I just want to mention about E. coli is it's an indicator species for other Coliflorum because it reproduces quicker and it's easier to catch. And so it's kind of great to know because if you know what's going on with E. coli, you likely have awareness of some of the other pathogens that could be getting into the water source. Because it reproduces really rapidly at that temperature, it's super important to get early, especially because you have long, well not long in Vermont, but you know, long enough spring to fall seasons where the populations could just get way out of control. So we, you know, again, this is not like a pointing fingers at dairy. They're just a big part of the agricultural industry in Vermont, like 80% pretty much, and actually 75 to 80% of the dairy industry actually is commercial, and they're the ones that need support in filtration systems. And so this place here is Shelburne Farms, which is a great spot. It's a 1,400 acre, it's actually a historic landmark. There's lots of camps there that happen. There's a lot of school programs. They have a diversified vegetable farm. And so it's a really good educational resource. And their dairy is done very commercially. So it's also a great place to kind of study. And one of the things that, this is the pit that we are gathering our slurry from. And one of the things worth noting is that this area covers a significant amount of lakefront. And they currently have one filtration system already in place that ends at an elm swamp. And just a reminder that like the natural wetlands of the earth are amazing filters. And so they have this checkpoints where Dana Bishop, the dairy farm manager, has her staff go out and take E. coli tests. And what do you think happens to the numbers as you go down? Any guess on the numbers? You think increase? Other guesses?
I'm trying to think if it's like filtrating on its way down.
Yeah, so this is up on the farm and this is
So
down at
it's
the lake.
decreasing.
Yeah, so
Yeah.
it does decrease. There's actually a couple of natural wetlands and also some human-made ones. And so it's actually fascinating, like between here and here, it's like clean by the time it gets to here, which is amazing. And of course, like no surprise. Yes?
How far from the farm to the lake was it?
That particular, I'd say it's probably like a mile and a half. Not counting topographical details. So the spot, yes.
No, go ahead. I'll ask it when I finish.
Okay.
Just because it's off topic a little.
Okay, hold on to it though. Okay,
For
so the dairy farm's located right here, and the place that is of concern is this beach here, which is a gorgeous area. I go swimming there, try to just like bless it and listen. Whenever there's a big rainfall, there's a sign on the beach that says the area is closed because of high E. coli counts. There's no filtration system right here, and they would like us to put in filtration system. So that's exciting that we already have a place for phase 2. Let's see. So obviously we're going to be looking at topography, key line design, really thinking about swales and not just fungi. Plants and trees are also amazing filters. So that's kind of the phase 2 project, and it's good to know that we actually have a place to put that so that all of our first phase has actual practical relevance. The previous research that's been done, there's a lot of routine monitoring going on, and I think the main thing, I mentioned this earlier, how it's an indicator species. So it's definitely more valuable than just this particular circumstance. If we look at the history of mycofiltration, I actually think it probably happened in a lot of other countries in other ways, knowingly or unknowingly, but in terms of documented research, Paul Stamets back in the 70s out in Washington State noted places where there was problems with farms out there, livestock, and he was able to note like 100-fold decrease in coliform counts due to putting in some fungal mycofiltration. And there was a bunch of different species he tried in different studies, oysters and Kingstropharia, and originally we were going to do like both, but most of the data that we found pointed to Kingstropharia being more effective than oyster ultimately. And I guess I'm also going to point out that we learned right off the bat that anytime you're trying to, find a mono something for a system, it's not going to work. So that there was a flaw in our initial research design looking, because we didn't find any that had multi-species, but just thinking because this is the one that worked the best doesn't necessarily mean it's the one that's going to work great, because we can never solve a problem alone. We need to have a team. So that's kind of just a seed for what we'll share later about bringing in more species than just one. So the questions that we had based on that research was, which species is most efficacious for, degrading and removing E. coli before it gets into the aquatic? What's the thickness of the mat? And obviously, depends on the particular farm and topography, is going to be the most effective. And also, what concentrations of dilution, can it handle? Is there a point where the mat is too saturated and won't work? Or so these are kind of the questions that there were gaps in of the studies that had been done and kind of guided us in designing our research.
Just a quick question.
Yeah.
Would the size of the mat or the thickness of the mat be dependent on the flow of the water?
Definitely.
The speed and
Yes.
the rate?
And so we worked that into our study. We're actually going to be filtering next week, and we're definitely doing, we're timing how fast the water goes through as well. And that's a huge part, is it's obviously not going to be that steep, because you want to have contact time for enzymes.
To work,
Yeah, but sometimes you have crazy rainstorms.
So could you slow down? Could you have a process that would slow the water down?
That's the
before
hope.
It gets to the.
Yeah, I mean, basically, between phase 1 and phase 2, we have a huge amount of time.
Yeah.
Because it's there's a whole bunch of other questions
course,
that's
yeah.
You gotta slow down.
You gotta do the study.
Yeah.
You gotta
Yeah.
experiment.
But
for
that's
sure.
good to think about. Not sure what happened to our slide here, but it said Kingstraferia.
We'll use our imagination.
So this is actually from, this is from Hannah's dad's garden.
Yeah. It's just a wild Kingstraferia, probably the size of my hand. Big mushroom.
And it's a great mushroom to cultivate because it's pretty easy. It's pretty voracious in terms of like eating up substrate and competing with other species, and can deal with like a relatively high flow rate. And in terms of the mats, its mat is okay based on mycelium. So this, Hannah and I did a lot of DIY cultivation, practicing from like liquid spores, and practiced a lot on like cold pasteurized straw, worked great, and then moving to hardwood chips. We had like a little lab. We have now a different lab, but we had a little one just in a basement. Worked great. That's with kids finding them. But pretty much it was great to learn a little bit about cultivating it and what it needed. But then for the research project, it became clear it actually needs pretty particular conditions. One of the things that we found out about is that besides keeping temperature constant and water, like soaking your substrate really well, it's not going to necessarily show up as quick as things like oysters. So if you already have a couple things already living on your wood, ideally we got the wood chips like 2 to 3 weeks after they were cut. But it's worth noting that, I'll just say it's humbling, okay? Just say.
Yeah, we'll dive more into
Yeah, just say that. So how it works, the mechanism, it's more complicated than this, but the simple mechanism is basically that the mycelium is releasing enzymes, and it's almost like an external stomach going ahead of it, and when it interacts with E. coli, it can break it down, degrade it in such a way that like the DNA will stop replicating and will die. And then there isn't a lot of research on contact time. Like originally we thought that would happen instantly, but it seems like it actually needs to have like 12-hour, maybe even more contact time for like full enzyme penetration and interaction. And I just want to note that in the winter in Vermont, because we have long winters, the polypores were really just in the woods this winter very present in my awareness, and have come into the study in a way that I think they're going to just be really helpful in looking at how the substrate they form with trees and kind of have their role in the forest and in the ecosystem. So this originally workshop was for people who wanted to get into research and don't necessarily have an academic connection, like getting a master's or a PhD. So this slide was just, I just had slides explaining like the trail of how we connected with UVM, which is the long and the short of it is I was working as a research scientist for a different project, and then they wanted me to get into entomopathogenic fungi, and I didn't feel comfortable studying fungi that would be like killing this other organism, this type of non-native worm. It just felt scary to me. So I kind of stepped out of that project, but I finished the previous one. But the connections I made with the people that I did work for were solid enough that then when we wrote this grant, the statistician and the professor were like, yes, let's partner. So that was just great to like keep that connection. Definitely listening to turtle wisdom. And then we knew we wanted to like bring it to the farmers, but because it's such a delicate topic, like at the NOFA conference, my approach has just been to like work with the kids and teach them about fungi. Because, you know, there's not a lot of curriculum in elementary and middle schools about fungi, and there's just not a lot of mycoliteracy like most of us. I feel like what I know now I should have known when I was like 12, and I'm like a 12-year-old with my myco knowledge, maybe 8. So, I don't know what's happening here.
I do not know why it says that.
Okay. So this is a sign that Hannah made. It's awesome. It's on the greenhouse door. Well, it's not there anymore. When we were at UVM in the greenhouse. And the part that I think is worth noting is just the application for swales, wetlands, riparian buffers, and rain gardens by farmers and other land managers to improve watershed health. So the hope of this study is that it's like replicable enough that people can apply it in various different contexts depending on the pollutant. Obviously you'd have to change things up depending on what you're dealing with. So our objectives, we're testing the hydrological throughput, like again talking about the map dynamics, 3 different effluent concentrations. So we basically obviously wanted to work with dangerous concentrations, so it's relevant. So we picked low danger, middle danger, and high danger. And then finally, we just did 2 thicknesses of filter at this point. That's obviously a place that needs further exploration for phase 2. So based on the data out there, you've probably seen this in your own counties, that the EPA and the FDA and your local watershed groups are going to all have different numbers. But like the overall consensus is that between like 80 and 120 per 100 milliliter is like an acceptable level of E. coli. So that means that you can swim in it and you can drink from it. But then once you get like above 125, you have low danger. So we use this to kind of determine our dilution rates. And so our most dangerous level was like 500 bacteria per 100 mil. And so that's just a certain amount of effluent we have to put in dilution. The next was 250 bacteria per 100 mil, and then the final was 125. So that's just different dilutions that we're creating. And so, well, let me just explain. So basically we have 36 bins, and we divided the bins. It's 18 bins are inoculated and 18 are not, so we have controls. Of the 18 that are inoculated and of the 18 that aren't, half of them are full and half of them are half. That's the nice little map. And then there's 3 of each of those that get one dilution, the other. And so basically it's just enough replication so that our data is statistically relevant. The team that we have is XScore, which is this organization through UVM that wants small businesses to get funding and move forward in furthering research. UVM, Mycofiltration is like a small LC3 that I co-facilitate, does earthworks, education, and research. And then Alex Dorr is on our team as a consultant, Mushroom Revival. Hot Terrain is something Sue Van Hook, our superhero mentor, facilitates. And then Vermont Myconode is like a radical mycology group that Hannah and I and some other friends started in our community. Travis Berg is here holding it down. So this is kind of the team. And I'm sure wherever people are that some university has some sort of like pilot opportunities that you could try out for watershed restoration. Maybe, I'm not sure, but it's probably something like this in most universities. So that's just a good thing for people to note, that partnering, they want to find places to plug in and use their rich facilities to further propagate good research. So just to note for phase 2, because we really want this to be a regenerative study that's relevant and not wasting resources, Shelburne Dairy, as I mentioned, really has a spot for us for phase 2. They're excited. Lake Champlain International is an amazing organization that not only educates about watershed health and like fish derbies, and they also send out bullets every couple weeks about the amount of sewage overflows that happen in the lake. And they're really good at documenting. It's actually disturbing. It's no surprise. We shouldn't be pooping and drinking water anyway. We should be building soil, but for some reason our system is built that way. So they are really good at tracking pollution, and they actually have a program called Blue where they help every household and business that wants a free watershed-friendly assessment, and they'll go to your house and like help you gutters and rain guard. They'll give you suggestions, and they're interested in us creating like a fungal pamphlet. And I'm like, we're not ready yet, but at some point we hope to be able to provide something of like mycofilters much further down the line. Keyline Vermont, Mark Kratchak, probably some of you know him. He's a well-known permaculture teacher. He focuses on like hydrological topography. He'll be on board. And then some UVM cooperative extension helps us link with like the dairy industry. So that's really great that we have that for phase 2. These videos, I guess Hannah's going to take over for now. These are the UVM professor and the statistician from UVM that we're partnering with.
Yeah, I'd like to introduce them and have their voices join us. Everyone want to stand up and just take a quick stretch?
If you want to, feel free.
Actually, I'm not sure. Yeah.
What kind of devices do you use to measure the rates of bacteria per milliliter of water and just like the process in general?
So
We're gonna go through.
oh yeah, we'll get into it a little
okay.
bit. We're
So,
about to
we're just
introduce
gonna wrap
them and
up
then
the team.
but
Step
keep your
ahead.
questions in case you
Yeah.
want to answer them.
Yeah. So.
Do you want me to talk about them? Or
Yeah.
Okay, so these are great folks, super grateful to them. Joseph is like a worm expert. I worked for him like studying non-native worms across the Northeast, how they're affecting maple forests. So he could, any worm you have, he'll identify, tell you where it's from, what it's doing in the ecosystem. He's a soil scientist, teaches at UVM. He's from Germany, really mellow, brilliant, humble man. And Arash is from, forgot the area in Iran, brilliant statistician, and he's actually heading up the International Saffron Project. So if anyone's interested in growing saffron, it's a great thing that medicine can grow in this region. And so that they're the folks I worked with before, and they're on board and been really helpful. Sorry you can't hear their voices.
Yeah.
Oh, I thought you. Okay. I thought you.
The thing, or I think there's one more slide. Oh, okay. No,
Yeah, I
it
think
is.
you're gonna hand
Okay.
this over to research technician.
So I'm going to talk about our methods, and I mean, as Jess pointed out, this is like the pilot project part of a larger project, and in some ways, like, you know, phase 2 of this project will be more in the field and a little more real, and there's transitioning from in plastic bins to like an actual stream. There's all these other variables that are hard to mimic in this, but and also to some extent this will be a little bit of an overview of what not to do and what we would do in future. We learned a lot on this project, and after one phone call with Trad Cotter, he said something that really resonated: fail forward. So we had a lot of successes, and I mean, I said, oh my god, sometimes I was like, oh, this project is cursed, but Jess pointed out it's also blessed in a lot of ways, and so huge thanks to Vermont Myconode for helping us out in some instances. So first, don't be healthy when you do a project like this. We had a lot of plastic, and when we were creating the bins, we had spigots on them to take dilutions out, and we used silicone to attach those. And we did this in a garage, but also like it was open, it was in a well-ventilated area, but we also like sometimes would, to get the silicone all the way around the spigot, we stuck our head in there, and it was a little too much contact time between us and the silicone thing. So just be careful, this stuff is kind of bad for you. And so here's the spigot. It's a little faint, and Alex told us to put a this little filter. It's a little screen so that wood chips don't get into our spigot and then clog the whole thing. So that's a do. And it's got a bunch of silicone around it, and so those are all the bins after a whole day. All this stuff takes way longer than you think it's going to.
And I would just say that, you know, we're always thinking, how can we do this more ecologically conscious? So our like trophic cascade challenge is like, can we use beeswax instead of silicone? Instead of like 66 quart plastic bins, could we like contact ecovative and find like some mycelial bin to use, like ideally?
So we're filling these bins up with wood chips. We're at the UVM Horticulture Farm in Shelburne for this, and so Jess said we have 36 bins. Half of them are totally full with wood chips. That's like 10 inches. We measured the volume of each, and then the other half are like 6 inches, 5, 6, a little bit of variation because the size of the wood chips is different. But and then half will be inoculated and half will remain uninoculated. So it's great that we have our research partners helping us with some physical labor right here.
I'm glad the volume's out
It's sped up double time.
Yeah, I was.
Yeah, chipmunks working with wood chips. We really are. Yeah. So this is our wood chip aisle, and you said it was about 75% hardwood?
Yeah, and it was like 3 weeks old. There's debate, 2 or 3 weeks, but that was with everyone's schedule when we could do it.
Yeah, and when we presented this earlier in the week for the Advanced Myco Renewal course, Maya pointed out, so here's all the bins, she said, you know, if there was like that 25% that's hardwood, softwood, yes, thank you. Conifers. She might even wait longer than 3 weeks actually, because like the hardwoods and the conifers all have their kind of toxins in them, so you want to give it at least 2 weeks to let those dissipate so they don't kill your mycelium. But the conifers may have more antifungals in them, so maybe waiting longer. But at the same time, there was the 75% hardwood, and you know, there's some variation among the chips themselves. Like there's kind of one side is like, we called them nicer wood chips. We made note of that, and then some of the others are a little. We noticed a few things growing on them, not in huge abundance, but and we knew this wasn't going to be sterile anyway. But we're gonna look when we get all our results. We're gonna look at and see, you know, were the ones that had the nicer wood chips, did they do better or not? And then this is a don't. We put all our wood chips in the bins, and then we drove them to the UVM greenhouse to inoculate. And ideally, we would have done those two things together, like add a layer of wood chips, and then give it your spawn layer, and then put some more wood chips over that.
But we couldn't because you want to hydrate your substrate first, and there were just logistical things about water at the farm.
Yeah.
And if we did have to do cars again, maybe we could do like bicycles and horses. You know, petroleum trail.
Yeah. Do it at Paul Smith College and get some draft horses.
Amish
to
on
walk
the research.
What?
Some of the Amish to join your research.
Yeah. So that's fun. Mycelial caravan. So this is our walking to the room. Hopefully nobody gets motion sickness from any of this. Sorry. But here's our room in the greenhouse. We were actually in the room across from it, but it like had the fan issue, so we lugged them all over across there. And then eventually we recently got kicked out just because this is a plant greenhouse, and insects like mushroom mycelium, and so it appeared that some fungal gnats.
Yeah, basically, the project went much longer than we thought based on inoculation rates and just things we learned about inoculation that we didn't know, that were different than our small scale stuff this winter we did. And so basically the greenhouse manager called us and was like, hey, we're concerned the fungal gnats are a vector, because there's a lot of other scientists doing research in other rooms with plants from all over the world. And they were concerned that like these two things that it could be a vector for. So we just basically, I was away, and we like texted Travis, and he and my partner like moved everything to the barn of where we already had the myconode. So it's just a tip, like always good to have like a underground backup volunteer research group, because you can't have all your everything counting on, just like in permaculture, you can't everything count on one system. You have to have a lot of other ways. So luckily, thank you Travis, thanks Skull Hollow Vermont, he's now in the barn there.
And as far as we know, these gnats didn't actually.
No, everything's fine. I
infect
checked the
anything,
greenhouse
but
manager, everything's fine, but they just wanted to like get it out,
yeah.
get the population down.
So we've got everything at the greenhouse. We're now going to inoculate it with. Some of the bins are getting just one of these dishes. This is like 70 grams of spawn, and then the bins that are totally full with wood chips are receiving both of these, and that's like 140 grams of spawn. And yeah, so we there's the spawn, and this is what Stropharia spawn looks like when it's right out of the bag. When it's actually growing on wood chips, it looks a lot different, because it likes to when it's grown in sterile conditions, it doesn't really form rhizomorphs. It won't fruit mushrooms, and it likes to be with bacteria. But when it's growing on wood chips with bacteria, it grows in a very rhizomorphic way, which is maybe not the best if you're trying to create a physical water filter, because it leaves a lot of gaps for water to go through.
And maybe for E. coli to live in.
There's Jess inoculating. And so here we are. We realized what would have been good is to give these wood chips a long, like overnight soak to get them really hydrated. What we actually did was we gave them like a rinse, and we timed how long that took, and then we stopped it. And did the same for everyone. And throughout like the few months that we had these chips, our crew still have them, but we did go back and water them. one thing that's really important for Stropharia is they don't like to have wet feet. So you do, like we would do this and then we would drain off the excess, or even if you do soak it for a long time, you want to make sure there's no water pooling in the bottom.
So we ended up doing a bunch of 12-hour soaks, like every 2 weeks.
Yeah.
Then we don't need to do it anymore.
Yeah, so we did do that, and that was a lot better for our mycelium. It just would have been great to have done it the first time.
We also had to re-inoculate.
Yes. So the amount of spawn we put in there was perhaps not enough. You know, if our substrate was sterile, if it was more hydrated, maybe this amount of spawn would have been enough. What was the
We
ratio?
were given, one of our technical advisors told us that we should do 5 pounds, what was it? Was it 5 pounds per yard?
5-pound bag
Per yard, which actually worked really well on pasteurized straw this winter. And then when we introduced like wood chips slowly, it was like way too low for this. And so we actually went back and we doubled it. And within like a week, we just saw the mats like thicken up really nice. So
I think it's from the projector. It's coming from here.
Yeah, I got it muted on the computer though. I thought it was funny at first. But
20 to 15.
Yeah, there's a mute button. There could be a mute button there, but I'm not. Yeah, that's fine.
We did like 5 pounds per yard, and I'm hearing now like 20 pounds per yard would be ideal. I mean, I don't
It's
want to
always good to
waste
use a lot of
resources,
spawn.
but like err on the side of more, usually
Yeah.
err on the side of less. But in this case, when it's like trying to grow a mat,
yeah, I mean, maybe like if you're doing this a bunch of times, you start out with a lot, and then as you get good at this and know, you know, like maybe smaller wood chips too would help a smaller amount of mycelium eat it faster. So maybe you can like taper it down and kind of conserve resources once you get a good hang of it.
or if you have tons of time.
And so we did end up re-inoculating we doubled our spawn after a few weeks.
So
And
going
that did
from-
help.
So were you sticking at the 140 gram per?
Then it doubled to 280.
Okay,
grams.
so yeah, that changed. So you realized that.
So basically, got 3
Except-
times the original amount.
Right. Yeah, because just as a cultivator myself, like looking at the spawn versus wood chip ratio, it did seem very small.
Yeah.
So,
And we
I-
thought so when we were doing it. And
Yeah.
Anna was like, "This seems awfully,"
Yeah.
you know. But we were
But-
trying to be
Yeah.
smart with our budget. And
absolutely,
resources.
yeah. Testing.
Yeah.
We're newbies.
So you probably saw we kind of had to, since the wood chips were in there and we're like in a tight space, there's no place to put the wood chips and then inoculate and
Right.
put them back on.
Yeah.
So we kind of had to dig down, like create a furrow and then put the mycelium under there, pour the wood chips back over. And
Layers is like the best. Yeah,
layers,
layering.
I mean, it might depend on your species, Maya
True,
said. It
yeah.
also may depend on your substrate. If you've got more spawn and you're in
Yeah.
a jar, like shaking it up might
Yeah.
be the way to go. But like John at North Spore, where we bought the spawn, even said like when you break up mycelium, it's traumatic. So it's better to keep it all together so it's strong and has that community, and then can grow out from there. And he said it also might, like depending on where the best wood chips are, where it's most hydrated, it might
Right.
kind of grow up a little.
Yes, there's so many factors. Yeah.
Yeah. Do you want to talk about this part?
Sure. Yes, we did a randomized block design, and I already talked about full. You know, we had a couple different variables: full bin, half bin, 3 different dilutions, inoculated, not inoculated, and then we'll use a Nova, like for interpreting it. That's mostly it. Yeah.
So these are some of the other things that were growing in our bins. Just to note them, they weren't growing in a huge abundance. We saw oyster mushrooms growing in our bins, and we had a panic moment where we're like, oh my gosh, did we get the wrong spawn? Was it mislabeled? And we called up John, and he was like, nah, oysters just tend to fruit earlier than King Stropharia would. And this is probably just a wild strain of oysters since they're so aggressive. And our wood chips were sitting there for a little bit. So and I kind of think the other reason why they're growing was because we initially thought we were going to do oyster and Stropharia, and then we decided not to do oyster mushrooms, so it was like, well, I'm coming to the party anyway. Here's like some kind of slime mold. If you have any slime mold experts, maybe you can help us identify them. And then this kind of looks like, I don't know, we were wondering, is this insect eggs? But I think it might be a slime mold as well.
Yeah.
Yeah, and they have little stipes, so
Yeah.
those do.
If they, yeah.
Yeah, and Schizophilum communi, or split gill, and I think there's a campsite out there that is split gill.
I guess we're
This is a do. We diluted our manure slurry with 21 liters of water, and we didn't want to just throw all that water right into the bins and then break up our mycelial mat. So this is Trad's idea. We took some buckets and drilled holes in them, like 15 or 20 holes, and then I would hold this bucket, and Jess would hold the 21 liters bucket. She's stronger than I am. And well, yeah, you split them up, and then she would pour it, and I would move the bucket colander around so that it percolated the water over the chips and got it everywhere.
We
Without
picked 21
breaking them.
liters because that's the amount where like the full mats were fully immersed and like this level of water.
And this was a fun part because like the top of our mats, our bins were dry for the most part. We had a lot of air circulation in the greenhouse, not ideal. It was also a really hot summer too.
And there were shade cloths.
We did
Because at a
put
certain
shade cloth,
temperature.
yeah, and to try and keep some of the carbon dioxide in for the But when we put all this water in here, we actually got to like see our mycelium mats in the bins like for the first time and saw that they were, and this was after the second inoculation, that they had grown out of it. And we're like, a mat. So that was exciting. And then we would pour the water in, and then Jess would have a like 1 liter container, and she'd put it under the spigot, and then I would start the stopwatch, and we would measure how long it took for a liter to fill up. And then we take our 100 milliliter sample to be tested at the lab. And most of our times were like between 15, 20 seconds, some were like closer to 30, 40 seconds. There were two that were like 5 minutes, and we're like, this is weird. So we went down and Jess thought this, and turns out our little wood chip screen had fallen off. So those are a good idea.
And they were at a like 30-degree angle. We were just thinking about land topography and like what's realistic for water flow. Obviously we'd have to change that, but we were thinking of like what's a realistic water flow where these mats would like be sitting in a swale or some sort of rain garden.
Yeah, and as just mentioned a bit ago, we wanted to maximize contact time between our contaminated water and the mycelium, so we left them in there for 12 plus hours. Did you say the rate low? Most of them were 15 or 20 seconds for 21 liters to, no, for a liter to fill up. Okay. Except for two that were like 5 minutes, and that's why.
Can I ask a super quick question? So are you explaining it as though you had the spigot closed to fill the bins up and then it sit for a fixed amount of hours and then open it to release?
Yes. Thank you for clarifying.
Yeah, thank you.
And then, but there was one step that so we had our manure slurry, and just went to collect that from Shelburne Farms, and then we made our dilution. So like the most dangerous solution was like 4.2 milliliters of slurry to 21 liters of water, and then we gave that to the lab
We like
to
stirred
test.
it.
Yeah, it was well mixed. The math was all good, and we gave that to the lab. And then we came back over here and made more of those dilutions and put them in the bins and let them sit. And then the next day we did our filtration, opened up the spigots, did that, and spent so much time, so much sweat, so much lugging around mycelial bins. Good arm workouts though. And then that night, Jess gets the email from the lab, and what we wanted for E. coli cell counts would have been 500 cell counts per 100 milliliters, 250 and 125. And the highest one that we got back from the lab was before the mycelium had worked on it, was 34. And we're like, what? happens.
And we did get the straight effluent tested also, and it was like
Yeah,
off the charts.
off the charts.
And we would use that like an hour later. So we knew that something
So we knew that our source was good. Turns out you can't just dilute E. coli with water. It needs a buffered solution.
Okay, because can you just like does it so diluting it with water causes it to
Well,
Space.
that much water and that quickly.
So what we didn't know, and because there's not a lot of data on this, I mean, there's probably E. coli experts we haven't found yet, I'm sure. But
But none of
basically
us
like
were that.
osmotic pressure cell bursts. So if you imagine like they're all living this like anaerobic place, like happy,
We're just gonna-
and then they like get in this like major oxygen environment and like it's colder, like I think they just all had like died on contact with dilution. And so we have to create like a dilution solution that's like beneficial and easy for the E. coli to like still stay alive. And so the suggestions we've had are like 0.9% salt, like an isotonic solution. It would like make it easier transition for the E. coli to still live in the fresh water, create our dilutions, you know. So
now I'm curious
So
about
just like accidentally, dilution is the solution to our pollution. That's not
does
what
that
we wanted.
make sense? Do you understand that?
Yeah, but then I just got thinking to like killing E. coli with just cold temperatures. You know,
Right.
it's just another.
Yeah, it's a great awareness. Like who would have
Yeah.
thought? You know.
Just
Right,
install
like, I mean-
waterfalls everywhere.
Right, and that's why flowing rivers, the colder it is, the less, you know, bacteria and whatnot. And it makes so much sense, but
Not outside. Not.
Sorry, it was
no, you're good.
So
I'm good.
I guess one thing I would say, which might be a no-brainer to a lot of you, but wasn't to us, which is like your inflow, like don't get your inflow tests the day you plan to like actually create all your inflow
get your inflow
dilutions.
tests back and
Like
then
a week or two, or like a couple days ahead of time, just in case it's like totally off.
and that there's
Because we just wasted like a 12-hour day, and yeah, and a lot of water.
so we'll have to do it again next week. But an isotonic solution, that's one thing that's been suggested for us, but we're also concerned, will that negatively impact our mycelium? Or the digestive enzymes it might produce that would remediate E. coli? I go to Antioch, New England, and I emailed a student, asked my advisor, and she said, talk to Jill Felker. And she said she uses a phosphate buffer for her dilutions. So we're gonna look into that. Maybe that's one way to go.
And the last thing I want to do is add like phosphorus to the water. So I actually don't feel comfortable with that, and I'm probably not going to be open to that. Maybe I'll be open to it, but I think I talked to a couple people at this gathering. There's a couple micromediation experts here, and they all so far, the 4 people I've talked to, all said that 0.9% salt solution is probably not a big deal. King Shafari can most likely handle it. Ideally, if we knew this was going to be another variable, we would have had like double of each bin because it's a one-shot deal.
Right.
It's like if we do it, we won't know. Like
Or try both.
maybe try
Both
yeah
buffers.
ahead of time with a small sample in the morning, and that's what we're going to do. Is we're going to like try out a tiny thing and like check it.
Yeah. My friend was suggesting, why don't you just go get some stream water? That's buffered. That's like how you're going to do this in nature. So, I mean, that might introduce a lot of variables too. We'd have to test that and see what's in it. But another thought.
Interesting.
Trad has suggested, you know, if we can't find out what the salt tolerance of Stravaria is, maybe look at other land saprophytes and see what their salt tolerances are. So there are like some species, like Pulsodamix has a salt tolerant oyster, and that's like awesome. And then like, what's that other species? Lentinus?
Tigrinus.
Yeah. And Trad has suggested using that one in future studies too because it creates a really thick filter. So, in summary, here are some of our lessons learned. Cultivation is key for microremediation. You want to prioritize your mycelial health. Like, you've got all these logistics, you've got all these ideals for how your project is going to go, but like, you got to focus on making sure your mycelium is going to grow and it's going to be happy where it's at. So, all the conditions, all the exterior conditions, how you inoculate it, what you feed it, should take priority. And yeah, inoculate the right way, You want to slow the flow down and ensure a sufficient contact time between your contaminant and the mycelium. Said we used a lot of silicone, and we kind of don't feel good about that, but we also realized that maybe adding a little bit more right before we do dilution and filtration would have been a good idea because we had some leaks. So we lost some of our samples due to that. Well, I mean, we had enough to test, but we put like the 21 liters in, and then some of it would come out and like alter that volume. Yeah, and just having a good space really helps. So the mycelium has been moved to the Myconode lab, and we're going to figure out what's the best buffered solution so that we can ensure our E. coli doesn't get diluted and that remediates our pollution. And Trid had also suggested using Lentinus tigrinus or Ganoderma species or Trametes because they can or may be able to remediate pathogens as well, but they also create a stronger, more dense filter. Because again, King Stropharia or Queen Stropharia is really rhizomorphic, and you can just see like how ropey that is. And it leaves a lot of gaps for stuff to get through. Do you wanna?
Sure. So yeah, so future parts of every research project spawns a whole bunch of other research questions. So we're thinking about like successional filtration. Obviously in nature, like all these species can grow together. You might see a log with like Ganoderma, Trametes, and I haven't seen Lentinus on the same one, but they're near each other. So the idea of like maybe having, if you had like a system on land, you'd have a successional filtration system where it would go through. Or ideally, I'm interested in like a Hugel culture, fungal polyculture. So say you have like swales, and on the downhill side of the swale, you know, you put in your, does everyone know what Hugel culture is? Yeah, right, so it's like these, you put down the woody substrate, and say you already have like your Ganoderma and your Trametes going, and then later on you bring in like Stropharia, that might work and form like a much thicker mycelial mat.
So just building upon the different species building upon each other.
Which makes so much more sense. Like,
I like that.
yeah, I mean, have an ecosystem, you know.
You know, sometimes in studies we want to figure out like what does one specific species do. So
Yeah,
it's
it's
a little
hard
harder to
going from
quantify.
the
but-
lab to like the
Yeah.
the nature. You know, it's hard to replicate either or in either area.
Mhm.
So, but I think it's great.
And King Stropharia, like, it can't hold a mat together. Like, as Hannah, I don't know if the next slide might show
Yeah,
that.
yeah, I talked
Okay.
about that. It's been really humbling and interesting to see, like, in nature, probably a lot of this stuff is super fine-tuned, and it's definitely not as simple as, oh, just throw a bag of spawn and it's gonna, like, fix all your problems. It's definitely not that simple.
Yeah, so one of the reasons why that idea of Trad mentioned just, it also resonates with me with, like, studying polypores in the winter and trees and stuff is just, in terms of their, like, hyphae, if you look at them, like, in terms of microscopy, right, so technically there's like three, depending on what type of species, it has three different types of hyphae, like almost all of them have generative, which is either with clamps or without, and then more complex species will have like at least two, they're like generative and skeletal, and so like the generative would be like the straight ones, and the